let's move to the main bodies of presentation. Firstly, introduction. Well, kiwi fruit. Scientific name Actinidia deliciosa is an emerging fruit crop which is popular and suitable to the mid-hills and high hills of Nepal at an altitude of 1200 to 2500 meters above sea level. Besides fresh fruit, kiwi fruit has a tremendous potential for processed value-added products such as jam, jelly, candy, marmalade, wine, juice, etc. This shows its huge prospects to increase its production in the present context of Nepal. However, production and productivity is not satisfactorily increasing due to presence of different biotic and abiotic constraints. And according to Subedi et al. 2020, root knot nematodes are considered one of the major limiting pests of kiwi fruit. Root knot nematode, Melidogan species, are destructive and economically important plant parasitic nematodes that feed on roots and can parasitize almost every species of vascular plants, causing huge economic losses. Moving on to the statement of the problem, well, more than 40 to 50% of kiwi fruit orchard in Nepal, including kiwi fruit orchard of Warm Temperate Horticulture Center, is infested with the root knot nematodes, which is mainly due to unhealthy kiwi fruit seedlings distribution. In addition to these, aircan infestation in young seedlings results in poor growth, reduced productive year, quality and yield, and also decrease the resistance of crop against drought and diseases. Moreover, it has a wide range of host plants and ability to damage multiple agriculture crops. Lastly, there exists a dearth in effective root knot nematode management strategy in Nepal due to less research and innovation. Moving on towards the rationale of the study, the effective management of root knot disease will help in the production of healthy kiwi fruit seedlings, which in turn will make the adult stage more vigorous and productive with enhanced resistance against diseases and drought. Moreover, this study will assist the Warm Temperate Horticulture Center office to find out the effective control measure against root knot nematode to fulfill its mandate of healthy kiwi fruit seedlings production and distribution to the farmers. Well, before starting the research, we had certain objectives which are divided into general objectives and specific objectives. The general objective was to manage a root knot nematode on kiwi fruit seedlings using different plant extracts, biocontrol agents, and chemical pesticides, whereas the specific objectives were first one was to find out the effective control measure against root knot nematode on kiwi fruit seedlings. Second was to study the interaction between root gall index and reproductive factor of root knot nematode, and the last one was to study the interaction between the reproductive factor and growth parameters of kiwi fruit seedlings. Well, before and during the research, we reviewed different national and international journals, publications, research reports on different topics, and the topics are displayed on the screen. Well, moving on to the most interesting and knowledgeful section, materials and methods. Well, first one is the research site. Well, the research was carried out in screenhouse condition in Warm Temperate Horticulture Center. The screenhouse and kiwi fruit orchard is shown in the figure 1B, and the figure is extracted from the Google Earth. Well, before moving on to disease confirmation and pathogen identification, before starting the research, we had to confirm the presence of disease and also we had to identify the pathogen. And for this, we collected sample of kiwi fruit roots from the fruit orchard, and we found out that there were large number of root knots present on the kiwi fruit roots, and the sample is shown in the figure 2. In addition to this, we also collected sample of soil from the rhizospheric region of kiwi fruit roots for the detection of possible presence of root knot nematodes. And for this, we set up using sieve, machine cloth, and extraction tray, which is shown in the figure 3. The nematodes which were settled in the extraction tray were collected and observed in stereo microscope, and we found out a large number of second stage juvenile of root knot nematode, and the sample of second stage juvenile is shown in the figure 4. Moving on to seedlings preparation and transplantation, the fresh seeds were extracted from the kiwi fruit, which were water prime for 24 hours, and gibberellic acid was treated to break its dormancy and to make seed ready for sowing. Moving on, the treated seeds were stored in the germination tray filled with a mixture of 2/3 sterilized sand and 1/3 vermicompost and cocopeat, as shown in the figure 6. Seedlings at 4 leaf stage, that is 60 days after sowing, were transplanted at the rate of 1 plant per pot in plastic pots, having sterilized soil and vermicompost in the ratio of 3:1, and the sample of seedlings at 4 leaf stage is shown in the figure 7. Well, moving on to egg mass extraction and eggs collection, and for this, heavily knotted roots of kiwi fruit trees from WTC fruit orchard were used, and for this process, we followed the procedure described by Hussey and Barker 1973 and McCullough et al. 1973 with some adjustments. Well, inoculation of nematode eggs. 7 days after seedlings transplantation, 2 to 3 centimeter deep holes were made close to each plant with a plastic stick, and each pot was inoculated with the nematode eggs at the rate of 1500 eggs per pot, except in a non-inoculated control, which was nematode free, and it was done using a pipette and a plastic syringe. Moreover, after inoculation, holes around the plants were covered with the adjacent soil. Moving on, table 1 shows the detail of treatment experimental design set up in a study site. Well, the design of the experiment was completely randomized design with 3 replication and 8 treatments. Altogether, there were 120 number of pods, and the variety we used was Hayward. Treatment table 2 shows the treatment details used for the management of root rot nematode. Well, altogether there were 8 treatments. 2 of them were from botanicals, 2 of them were from biocontrol agents, and 2 of them were from chemical pesticides, whereas 2 of them were control. In inoculated control, nematode X were inoculated, but the treatment was not given, whereas in uninoculated control, neither nematode X were inoculated nor any treatment was given. The application dose per pot and the source of each treatment is shown in the table 2. Moving on towards the observation parameters. Observation was carried out after 2.5 months of nematode X inoculation. For this, each pot was taken to plant pathology laboratory of WTSC, Kirtipur, and each seedlings was carefully uprooted and observed for following parameters: gall formation quantity on roots, egg count, juvenile count, reproductive factor, plant height and shoot weight, root length and root weight, and the last one was percentage nematode control. Data analysis. Recorded data were tabulated treatment-wise under 3 replication in Microsoft Excel. NY analysis was done using the statistical software RStudio. Dunson's multiple range test was used to determine the significant differences among treatments, and regression analysis was carried out using Microsoft Excel. Well, let's move to the most important section, results. Firstly, root gall index and root galls number. Well, among the 6, we found out a significant difference between different treatments at a 0.1% level of significance for both root gall index and number of galls per plant, as shown in the table 3. The highest value of root gall index was observed in inoculator control with a value of 7.44 on the scale of 0 to 10, whereas the lowest value of root gall index was observed in the treatment Trichoderma viridae with a root gall index of 3.11. Moving on to number of galls per plant, the highest value of number of galls per plant was observed in inoculator control with 132 number of galls per plant, whereas the lowest number of galls per plant was observed in the treatment Trichoderma viridae with 18 number of galls per plant. Moving on to egg count, juvenile count, and the reproductive factor. Well, we observed a significant difference between different treatments in terms of egg count, juvenile count, and the reproductive factor, all at a 0.1% level of significance. The highest value of egg count, juvenile count, and the reproductive factor was obtained in inoculator control with a value of 4120 eggs, 299 juveniles, and 2.95 reproductive factor. Contrarily, the lowest value of egg count, juvenile count, and the reproductive factor was obtained in the treatment Trichoderma viridae with 333.33 eggs, 32.67 juveniles, and 0.24 reproductive factor. Percentage nematode control. Well, among the 6 different treatments used to manage the root knot nematodes, we found out a significant difference between these treatments at a 0.1% level of significance, as shown in the table 5. Well, treatment Trichoderma viridae was found to be most effective with the highest percentage of nematode control with a value of 91.71%. Followed by Fostia with 86.33%. Well, the lowest percentage nematode control was observed in the treatment Allium sativum extract with 61.86%, followed by Lantana camera extract with 66.66%. Moving on to plant growth parameters. Well, we observed a significant difference between different treatments at a 0.1% level of significance for plant height, shoot weight, and root weight, whereas we observed a significant difference between these treatments at a 1% level of significance for root length. The highest value of plant height, shoot weight, root length, and root weight was observed in uninoculator control with a value of 6 cm, plant height 3.70 gram, shoot weight 9.6 cm, root length, and 2.57 gram root weight. Contrarily, the lowest value of plant height, shoot weight, root length, and root weight was observed in inoculator control with a 2.93, 1.40, 4.79, and 1.02 gram respectively. Moving on to interaction between the reproductive factor and gall index. Well, we observe a positive relationship between the reproductive factor and gall index, and the equation shows that with a 1 unit increase in the reproductive factor, gall index will have been decreased by 1.40 times with 77% of coefficient of determination. Moving on to interaction between the reproductive factor and plant height. Well, we observed a significantly negative relation between the reproductive factor and plant height, and the equation shows that with a 1 unit increase in the reproductive factor, plant height will have been decreased by 0.48 times with 45% of coefficient of determination. Moving on to interaction between the reproductive factor and root length, we observed a negative relationship between the reproductive factor and root length as shown in the figure 10, and the equation shows that with 1 unit increase in the reproductive factor, root length will have been decreased by 1.02 times with the coefficient of determination value of 36%. Well, the discussions. According to authors Druzinina et al. 2018, Kubisik et al. 2019, and Santos et al. 1992, Trichoderma species can be used as an effective egg parasite of Melaleucan species which grow on the surface of egg masses and penetrated the chitinase egg cell, thus increase the percentage nematode control. Moreover, Trichoderma species can also be used, can also involve in the production of antibiotics and enzymes such as chitinase, glucanases, and proteases, thus plays a significant role in parasitism. In addition to these, Pseudomonas fluorescens also involved in the production of antibiotics, enzymes, and toxins against plant parasitic nematodes, thus they help in the reduction in nematode population. Moreover, garlic clove extract contains sulfur compounds which can be implicated in nematode control. And according to Talley and Cabori 22 lantana camera contains different chemicals like 11-oxytryptopanic acid, lanthanolic acid, lantoic acid, pumolic acid, and ursolic acids, which accounts for the antagonistic effect against root nematode. Moving on, similar observation was observed by Subedi 2022 on tomatoes, who found that a significant reduction in gall index count and juvenile count was done by Trichoderma viridie as compared to the control. Moreover, our findings align with Vaidya et al., who found out that Trichoderma viridie reduced gall index, number of food culls per plant, reproductive factor was just higher than our findings. According to Samili et al. 22, Trichoderma viridie led to an increase in stalk length, root length, and top face weight compared to the untreated control. According to Hermosa et al. 22, Trichoderma species can indirectly interact with roots, protects from nematodal infection, and thereby enhancing the potential for plant growth. Well, then what are the conclusion of this research? Well, firstly, Trichoderma viridie was found effective against root knot nematode, which had the least root gall formation along with the minimum egg count, juvenile count, and the reproductive factor, as well as the highest nematode control percentage. In addition to these, a significantly positive interaction between the reproductive factor and root gall index and negative interaction between the reproductive factor and growth parameters of Q-fluid seedlings was obtained. Moving on to recommendations for further research. Well, future research will be carried out using the same treatments in a Q-fluid orchard to determine their efficacy in field condition. Moreover, identification of Melaleucan species at WTNC Q-fluid orchards will be done to know about the phenology of pathogens in details. In addition to these, researchers are also encouraged to perform multi-location trial on different Q-fluid seedling nurseries using the same treatments. Lastly, different other biological treatments showing the antagonistic property to the root knot nematode may be used to control the disease. We are leaving some scope for future researchers. I want to acknowledge my supervising committee for guiding and providing critical comments throughout my internship period. I am very thankful to PMMP and Faculty of Agriculture AFE for providing this opportunity. I will be forever grateful to the staffs and members of Warm Temperate Horticulture Center in Kirtipur, Kathmandu, and I am very much obliged to Plant Pathology Division of NARC and Nepal Plant Disease and Agro Associates Private Limited, Kathmandu. I am very thankful to Assistant Professor Pratishtha Adhikari ma'am, and this research will never have been completed without the moral support from my intern friends and my brother Chiranjeevi Sharma. I have no words to describe about my beloved family, and at last I want to thank Lucky Boys Hostel Kirtipur, Kathmandu. Here are some of the references that I have used while preparing this presentation, and here are some glimpses of research activities, and thank you for your kind attention.
Thank you, Mr. Kapil, for your nice presentation. Now the floor is open for all the students participating in the presentation, and if you have any queries and suggestions, let him know.
Okay. Saurabh? होइन याप टेस्ट सिग्निफिकेन्ट भएपछि त हामीले डिएमएआरटी गर्छौँ नि, त्यही भएर त्यो राखेको हो। त्यसमा चाहिँ
नमस्ते,
याप टेस्ट सिग्निफिकेन्ट भएपछि त हामीले डिएमएआरटी टेस्टमा जाने हो नि त, होइन र? अनि कति पर्सेन्टेज लेभल अफ सिग्निफिकेन्टमा भयो भनेर त त्यही बेला थाहा हुने, होइन र?
Okay. Anybody other? Okay. Now I would like to request our external sir, Professor Dr. Arvind sir, for your valuable suggestion to Mr. Kapil.
कसले मैले सोध्ने
We are
कि
waiting for your comments. Yes,
ए
sir.
for me? Okay. Thank you.
We are waiting for you.
Okay. Thank you, Kapil, for your very nice presentation. Really, I am very happy that all of you are presenting very well. यो मास्टर्सको स्टुडेन्ट जस्तै तिमीले प्रेजेन्ट गर्दैछौ कि द्याट इज द भेरी गुड पार्ट कि एन्ड दिस सोज सुने कुरा
हजुर सर
अनि दिस सोज द्याट यु वेयर rigorously in touch with your major advisor, and because of his sincere guidance all of you are able to present very well के हैन त
हजुर सर
अब मलाई एकचोटि टेबलमा जाऊ त एउटा
सर you mean the table from result and discussion
ल यो एलएसडी भ्यालु तिम्रो छ नि
हजुर सर
यो एलएसडी भ्यालुको यो डेटाहरुसित के रिलेसन छ भन त
सर यो चाहिँ हाम्रो चाहिँ यो बीचमा लेभल अफ यो कति डिफरेन्स छ अनि यो चाहिँ यो बीचमा चाहिँ एट पार छ कि छैन यो दुईटा ट्रिटमेन्टहरु बीचमा चाहिँ सिग्निफिकेन्ट डिफरेन्स कति छ र यो दुईटा बीचमा चाहिँ डिफरेन्स छ कि छैन भन्नको लागि चाहिँ एलएसडी निकाल्नु पर्छ सर
एलएसडी के भएपछि डिफरेन्स हुन्छ
जस्तै के हुन्छ भने सर अब हाम्रो याप टेस्ट सिग्निफिकेन्ट भयो भने चाहिँ हामी लिस्ट सिग्निफिकेन्ट डिफरेन्स तिर जान्छौं अनि यदि हाम्रो दुईटा ट्रिटमेन्ट बीचको डिफरेन्स चाहिँ एलएसडी भन्दा धेरै आयो भने चाहिँ त्यो दुईटा बीचमा चाहिँ सिग्निफिकेन्ट डिफरेन्स छ भन्ने थाहा पाउँछौं सर
भेरी गुड अब अर्को कुरा मलाई यो भन हाउ यु काउन्टेड द रूट नट नेमाटोड्स
Well, sir, this is a very tedious process, and to be honest, sir, I have done my research at Warm Temperature Horticulture Center, but there was no facility for the counting of root knot nematode X, and we use lab from our adjunct professor Hirakaji Manandar sir, and for the counting, firstly we collected root knot roots having a lot of root knots, and these were chopped into smaller pieces, and the suspension was त्यसपछि चाहिँ सर हामीले त्यो रुट नट्सको त्यो सस्पेन्सनहरुलाई चाहिँ सोडियम हाइपोक्लोराइड सोलुसन 1% सोडियम हाइपोक्लोराइड सोलुसनमा चाहिँ रिन्स गर्यौं रिन्स गरिसकेपछि चाहिँ त्यसको त्यो जिलाटिनियस म्याट्रिक्सहरु चाहिँ रुट नटबाट चाहिँ छुटेर जान्छ र त्यहाँनिर चाहिँ एक्सहरु एकको चाहिँ एक मासेसहरु चाहिँ निस्किन्छ र त्यो निस्किसकेपछि चाहिँ त्यसलाई फेरि हामीले चाहिँ सिविङ गरेर सिविङ चाहिँ फेरि 100 मेश सिभ र 500 मेश सिभ भन्ने हुन्छ र 100 मेश सिभबाट चाहिँ त्यो एक्सहरु चाहिँ सबै के तल जाने भएको हुनाले तलपट्टि चाहिँ हामीले 500 मेश सिभ राख्छौं र 500 मेश सिभमा चाहिँ एक्सहरु चाहिँ र्याम माथि रहन्छ त्यो माथि रहेको एक्सहरुलाई चाहिँ हामीले बिकरमा चाहिँ कलेक्सन गरेर अनि निमाटोड काउन्टरमा लगेर निमाटोड काउन्टरबाट चाहिँ स्टेरियो माइक्रोस्कोपमा लगेर अनि त्यसपछि काउन्ट गरेको छ
यो मलाई भन्नु त यो पीआई नम्बर भनेको के हो
पीआई नम्बर भनेको इनिशियल पपुलेसन हो सर निमाटोड चाहिँ हामीले कति इनिकुलेट गर्यौं भनेको हो सर
अनि पीएफ भनेको
पीएफ भनेको टोटल पपुलेसन यो फाइनल पपुलेसन एक्स र जुवेनाइल जोड्दा फेरि चाहिँ कति भयो भन्ने आउँछ
एक्स र जुवेनाइल को सोध्दाखेरि हैन जोड्दाखेरि
हजुर सर
के जोड्दाखेरि
The total sum of final population of X and juvenile, sir.
त्यो गर्दाखेरि त्यति हो अनि तिम्रो यो फाइनल पपुलेसन जुन छ नि
हजुर सर
त्यसले स्ट्याटिस्टिकल एनालिसिस किन नगर्या
सर यो चाहिँ फाइनल पपुलेसन बाट चाहिँ हामीले रिप्रोडक्टिभ फ्याक्टर निकालिन्छ सर यो रिप्रोडक्टिभ फ्याक्टर भनेको चाहिँ फाइनल पपुलेसन बाइ इनिशियल पपुलेसन हुन्छ सर यसमा चाहिँ मेन सिग्निफिकेन्ट देखाउने चाहिँ रिप्रोडक्टिभ फ्याक्टरले हुन्छ क्या सर अब यसमा चाहिँ के हुन्छ भने यदि रिप्रोडक्टिभ फ्याक्टर चाहिँ ग्रेटर देन 1 भयो भने चाहिँ त्यहाँनिर चाहिँ निमाटोड पपुलेसन चाहिँ एकदम हाई छ र त्यसले चाहिँ हाम्रो क्रपलाई चाहिँ एकदम ह्याम्पर गर्छ भन्ने जनाइन्छ सर अनि हाम्रो अनि त्यही भएर सर यो फाइनल पपुलेसनलाई चाहिँ एनालाइसिस नगरेको सर
तर अलिकति कस्तो कस्तो देखिरहेछ के तिमीले टेबलमा राख्दाखेरि आखिरमा त्यो फाइनल पपुलेसन पनि त मेन भ्यालु नै हो हैन
हजुर सर
अनि मेन भ्यालुलाई पनि त गरे त राम्रै हुन्थ्यो त
हुन्छ सर तर हामीले चाहिँ मेन हेर्न खोजेको चाहिँ रिप्रोडक्टिभ फ्याक्टर भएर सर मैले नगरेको सर यसमा
त्यसो भए त्यो फाइनल पपुलेसनको नम्बर हटाइदिए हुन्छ नि त
हुन्छ सर
त्यो त स्वतः त्यो एग र जुवेनाइललाई जोड्ने बित्तिकै चाहिँ त फाइनल पपुलेसन आइहाल्छ हैन
हजुर सर मैले राखेको चाहिँ किनभने सर यो रिप्रोडक्टिभ
मैले बुझेँ तिमीले रिप्रोडक्टिभ फ्याक्टर निकाल्नको लागि राखे हो त्यो हैन
हजुर सर
तर त्यो नराख किनकि टेबलमा अलिकति कस्तो अड देखिरहेछ कि
ए हुन्छ सर, हुन्छ, हस्।
त्यो फाइनल त्यो इनिसियल पपुलेसन पनि नराख कि
ए हुन्छ सर, हस्।
है, त्यो चाहिँ नि गर्नु पर्यो। अनि अर्को कुरा, यो अब तिमीले केमिकल पेस्टिसाइड्सहरू युज गरेका छौ।
हजुर सर।
अब केमिकल पेस्टिसाइड इज अ भेरी ब्रड टर्मिनोलोजी के
हजुर
होइन?
सर, हजुर।
केमिकल
सरहरूले पनि यो पनि हालेर एकचोटि चेक गर कस्तो रिजल्ट आउँदो रहेछ, अनि हामीले स्टडी गर्नु पर्दैन, तिमीले गरे नि भइहाल्यो भन्नुभएको थियो, अनि त्यही भएर मैले काटा भाइट क्लोराइड नै युज गरेको छ।
अब त्यो जुन तिमीले पेस्टिसाइड युज गर्यो केमिकल, द्याट इज अर्ग्यानिक अर इनअर्ग्यानिक पेस्टिसाइड?
केमिकल पेस्टिसाइड्स बोथ आर इनअर्ग्यानिक सर।
हो, अब यो जम्मै कुराहरू यु हेभ टु मेन्सन इन योर इन्ट्रोडक्टरी पार्ट के है, और इन योर मेथोडोलोजी। यो सबै कुरा छोड्नुहुन्न, किनकि द रिडर शुड बी भेरी मच क्लियर विथ द थिङ्स यु हेभ मेन्सन इन योर रिपोर्ट।
यस सर, आई हेभ इन्क्लुडेड सर इन रिपोर्ट सर।
हो, एक्जाम्पल दिन सक्छौ इनअर्ग्यानिक पेस्टिसाइड्सको केही एक्जाम्पलहरू?
इनअर्ग्यानिक पेस्टिसाइड्स फुस्टियाजेट भइहाल्यो सर।
कति ग्रुपमा हुन्छ, कतिवटा हुन्छ इनअर्ग्यानिक पेस्टिसाइड्स?
आई हेभ क्लियर।
एकमा तिम्रो चाहिँ नि अर्ग्यानो क्लोरिन्सहरू हुन्छ होइन, कार्बामेट्सहरू हुन्छ, सल्फर कम्पाउन्ड्सहरू हुन्छ, त्यस्तै इन्सेक्टिसाइड्स अफ प्लान्ट ओरिजिन हुन्छ होइन। त्यो कुराहरू एकचोटि रिभाइज गर, बिकज your topic is very much related with the pesticides. So you should be very much clear with the concepts of pesticides, that what is inorganic pesticides, what is organic pesticides, what is nematicides, because you are working with Milledogyn species, so you must be familiar with the nematicides which are in common use, although it is not commercially used in our country, but also is the popularity of nematicides is also increasing. अब अर्को कुरा भन्नु, what is the reason of the cause of root knot nematodes in the soil, भन त?
Well, in Nepal, the major cause of root knot nematodes in our soil is that due to the haphazard import of seedlings from the foreign countries, sir.
सोइलको चाहिँ नि पीएचले, what is the relation between soil pH and nematodes?
Well, sir, it is inversely related. As the pH increases, root knot nematodes population decreases in soil.
भन्नाले जब pH soil alkaline हुन्छ भने
हजुर सर,
नेमेटोड घट्ने हो?
हजुर सर।
एक्चुअली कन्फर्म हेर है।
Yes, sir. I have included it in my literature review, sir.
Okay. Include, go through again, review, revise, and include all the things. Okay, thank you.